Hello everyone. Today we are going to discuss lecture number 13, starting methods of single phase induction motor. In this method there are four types of methods basically. Depending on the method of starting, these are four types of single phase induction motor. Number one method is split phase starting method. Number two is shaded pole starting method. Number 3, repulsion motor starting method, and number 4, reluctance starting method. We all know that single phase induction motor with main rotor stator winding has no inherent starting torque due to pulsating air gap flux. So depending on the starting torque, rotating air gap field at the starting must be introduced. So these starting methods do nothing, but they are used to convert this pulsating magnetic field or pulsating air gap flux into rotating air gap flux so that the rotor can start rotating. So number one, we will discuss the selection of the suitable induction motor for various applications are chosen by depending on the torque speed characteristic of load and duty cycle of the machine and starting and running line current limitation. These are the parameters on which the different types of machines are chosen. So let us start with the first type of induction motor. The first machine is split phase using split phase starting method. Single phase induction motor employing this method of starting are called split phase motor. All the split phase motors have two types of stator winding. Number one is main winding, number two is auxiliary winding. Both of these windings are connected in parallel with their magnetic axis spaced at 90-degree electrical angle. These split phase windings we are already talked in last lecture. So how these are placed? These are placed 90-degree electrical in space. It is known that when two windings are spaced 90-degree apart on the stator and excited by two alternating EMFs that are placed 90-degree in time phase, then a rotating magnetic field is produced. So this is the basic principle how rotating magnetic field is introduced in the single phase induction machine. If the two windings are connected in parallel to a single phase source, the field produced will alternate but will not revolve, since the two windings are equivalent to one single phase. If impedance is connected in series with one of these windings, the currents may differ and in time phase, thereby introducing a rotating field. So impedance has to be connected in series with one of these two windings placed on the stator, so that a time difference in phase can be produced and resultant rotating magnetic field is produced. So the first motor resultant split phase starting method uses four types of methods. Number one is resistor split phase motor. Number two is capacitor split phase motor. Number 3 is capacitor start, capacitor run induction motor, and number 4 is capacitor run induction motor. So we are discussing in this lecture resistor split phase induction motor. The stator of split phase induction motor is provided with an auxiliary and main winding in stator. So starting winding is placed 90-degree electrical from the main winding, as shown in figure. The figure is shown as like this. This is how 90-degree electrical starting winding and the main winding are placed from each other. This is rotor, and this is the physical diagram of the single phase induction motor, and this is the phasor diagram of the induction phase motor. So let us start reading again. Now this is working. The starting operates only during the brief period when the motor starts up. The two windings are designed so that the starting winding has high resistance, relatively small reactance, while the main winding is having low reactance and large reactance. So what this will produce? Resultant, we are having currents flowing in the two windings, reasonable phase difference of 25 to 30 degree, which can be seen from this diagram. The resultant difference between currents is 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 shown here, and this is Im. The resultant angle is having a difference, phase difference between them. So a resultant current is produced, which is making a phase angle with voltage. So the resultant current is rotating. Let us see how it is working. When the two stator windings are energized from a single phase supply, the main winding's current Im, and the starting winding carries the current Is. Since the main winding is made highly inductive while the starting winding is highly resistive, currents in the Im and Is has a reasonable phase difference. Consequently, a weak revolving field approximately to that of two-phase machine is produced, which starts the motor. The starting torque can be given by the formula Im Is sin phi. So this is the starting torque. Resultant, when K is constant, when the motor reaches to about 75% of the synchronous speed, the centrifugal switch opens the starting winding and only the main winding remains in the circuit. The motor then operates as a single phase induction motor and continues to accelerate till it reaches its normal speed. So this is the working principle for single phase induction motor of split phase type, resistor split phase type motor. Characteristic, the torque is 15 to 2 times of the full load torque. Starting current is 6 to 8 times of full load current. So due to their low cost, split phase induction motor are most popular in single phase induction motor in the market. Since starting winding is made of fine wires, the current density is high and winding heats up quickly. If the starting period exceeds 5 seconds, the winding may burn also. So the motor is protected by a built-in thermal relay. This motor is therefore suitable where starting periods are not frequent. So these machines are only preferred where starting periods are not very having large time period and running period is more. That's the important characteristic of this motor is that they are essentially constant speed motor. These are constant speed motors also. Speed variation is only 2 to 5% from low load to full load. And this is all about the diagram. This is the top speed characteristic, starting torque and starting synchronous, starting torque at speed 0, and this is the speed 0. When speed is equal to synchronous speed, the torque is 0. What are the applications? These can be used in fans, washing machines, oil burners, small machine tools. And the power rating of such motors lies between 60 to 250 watt. So this is all about resistor split phase induction motor. We will discuss the further more types in the next consecutive lectures. Thank you very much.